we have been given the commutator of two matrices as AB equal to AB minus BA, and the anti-commutator is something AB plus VA. And if the anti-commutator is 0, then what is the commutator of A with BC? That is the question. Obviously the answer has been given here, but let us solve this problem step by step, and how do we get this result. Okay, so let's start it. So we have, to start with, we have two operators A and B, and the commutator of A and B is defined as AB minus BA. The anti-commutator of A and B is defined as AB plus BA. Okay. Now in the question we have been given that AB anti-commutator is 0, which is basically AB plus BA equal to 0, which basically means that AB equal to minus BA. Now the question is that what will be the commutator of A with BC? What will be this thing? Okay, so let's do it. So we know that A with BC commutator is given as AB with C plus B with AC. Once you take C outside and you do the commutator of A and B, and then you take B outside and do the commutator of A and C. And this thing you can write it as AB minus BA with C plus B into AC minus CA. Okay, and this thing will be ABC minus BAC plus BAC minus BCA. So you can see there are two terms which will cancel, so let's cancel them, and you get here ABC minus BCA. But you can write AB as minus BA from here, so you can write here minus BAC minus BCA, and from here you can take minus B common, and this thing is basically AC plus CA, which is minus B of anti-commutator of A and C. So you get commutator of A with BC in this case is minus B AC, which is the correct answer, and it is C. Okay, let's look at another question, the question number 2. We have been given the waveform x of t as the following diagram, and they ask that the Fourier series for x of t which gives the closest approximation to this waveform is what? Now there are 4 options obviously given here, and we have to find the one which closely matches with this waveform given here. Okay, so let's do it again. Now sorry, let me select the right pen. Okay, so given a function f of x, you can write it as some constant a naught by 2 plus some constant some summation n equal to 1 to infinity a n cos nx plus sum n equal to 1 to infinity bn sin nx, where a naught is 1 by pi 0, sorry, minus pi should be here, minus pi to pi fx dx. An should be 1 by pi minus pi to pi fx cos of nx dx, and bn should be 1 by pi minus pi to pi f of x sin nx dx. Now you can see that since cos is an even function, an basically contributes to the even part of the waveform. Sin x is an odd function, so bn, this bn contribute to the odd part of the wave function, and this a naught is just a constant shift. So you can look at the wave function here, sorry, the waveform here, and you can see that the waveform is basically completely odd, like it's symmetric about origin. So it's obvious that the only contributions which are coming here, they are coming from sine and not from cosine. So we should have expansion in terms of sine only. So obviously option A doesn't match, option D doesn't match. Now the only two options which match are B or C. Now to find out which is the correct answer between B and C, what we can do is that we can find the value of the function as, say, t by 2, like when we put t by 2, and when we put t by 2, the value should be equal to 1. Now clearly for this one at t by 2, the value of the waveform is the value of x is negative, while for this one we get plus 1 if we substitute here. So as t tends to t by 2, we basically get terms like 2 by pi into sine of pi into t by 2. So this is basically, and there is t here, to t cancel, so sine of pi by 2, which is 1, minus half into some 0 like terms and other terms, basically whatever. So basically we get a positive term here. The dominant contribution is positive, and that's what we need here. The dominant contribution at t by 2 should be positive, while for this one the dominant contribution is negative. So obviously option B is not there, and option B is not the right option, and A and D, they are not the right option because they completely they are completely made up of cosine, which is an even function. So the right option is C. Okay, so we have solved A and question number 1 and 2. Let us look at problem 3. So problem 3 is about a solid tetrahedron which has the following projections when seen from 3 different sides, left, top and right, and when viewed from the front its projection will be. Now I will leave this question to you because this is more about visualization and all, and I think you should figure out yourself. So I will write here simply figure out yourself. Okay, let us do problem number 4 now. So we have been given a small elastic ball of mass m which is placed at the apex of 45-degree inclined plane as shown in the figure. So this is the inclined plane and this is the ball, elastic ball. So elastic basically means that when it hits a surface, like I think it will go through elastic collision. Like this basically means that it will not deform and all when it collides. Now the ball is allowed to slip without friction down the plane along the dotted line, hit the ground as shown, and bounce along it, like it bounces and then goes like this. If the height of the inclined plane is h, if the height of the inclined plane is h, and the coefficient of restitution between the ball and the ground is 0.5, then what is the distance AB marked on the figure? Okay, so let's do it. Okay, so this is our inclined plane thing. Okay, let's draw this thing is the surface. Now the ball is somewhere here and it has mass m. This height has been given h. This angle is 45 degree. Now it falls down here, slides here, then it jumps and they just keep on moving. Now let's call this point A and this point B, and they are asking what is the distance AB, and let's call this point C. Now since the ball falls from here, when it comes down the ground here, by conservation of energy of mv square, if the v is the velocity here, should be equal to mgh. Now cancel m both sides, then the v should be equal to root 2 gh. Now AC in our case should be equal to h, because this is 45 degree, this is 90 degree, so this should be also 45 degree. So basically this height should be equal to this length. So AC should be h, which is basically equal to, let's say, call it point h, like this, call it some point O. So OA. So OA equal to AC equal to h. So what we, to calculate AB, we need AC plus CB, and we have already AC, which is h. Now we have been given that the coefficient of restitution, let's denote it by E, is half, and coefficient of restitution is basically relative velocity after collision divided by relative velocity before collision. So it's velocity, select the relative velocity after collision is after collision, call it like V relative after collision divided by V relative before collision. Now since the geometry is such that the ball falls like this, so if we break the velocity is like this V, and this, since this angle is 45 degree, there will be two components, the vertical component, and there will be one horizontal component. Let's call them Vx and Vy. So Vx is basically root 2gh cos 45 degree, so that is root gh, and Vy is also root gh. Now after collision, suppose the velocities become Vx prime and Vy prime. Now since the only velocity that should change is the direction along which the force is applied, so the force will be applied along this direction, and hence only y component of the velocity will change. So our Vx prime should be equal to Vx that will be root gh. On the other hand, by prime will be equal to root gh divided by 2 because the coefficient of restitution is half. So we can say, like, let denote them by so let's say vx prime is v prime, some speed v prime cos theta, and vy prime is some v prime sin theta. Then the length, the range that it should go, cb, should be equal to v prime square into 2 sin theta cos theta by g. See, this is simple formula to calculate the range when the x component of the velocity is this and y component of the speed is this. So the range r, which is in our case is bc, I guess, yeah, cb or bc, is this much, and that is by simply substituting is 2 into root gh into root gh by 2g. Now 2 cancels and this thing is just h. So our AB is h plus h equal to 2h. So that is the option B.